Good afternoon. So this is Dr. Avdhesh Gupta, Professor from Department of Information Technology, Ajay Kumar Garg Engineering College, Ghaziabad. Today we will discuss about the topic transaction processing that is related to Unit 4 from DBMS. So transaction processing system. So basically we will discuss the following content: transaction concept, different types of transaction state, what is concurrent execution, how will we ensure that these transactions will be executed in parallel, seriesability and testing of seriesability. Okay. So transaction concept. What do you mean by transaction concept? Basically, transaction in general term, transaction is a term where we want to change, we can change the value of any variable. So transaction is a unit of program execution that access and possibly update various data items available in DBMS tables. Okay. So let's say, for example, if we want to transfer some amount from one account to another account. In this example, the transfer of rupees 50 from account A to account B. So first the DBMS will read the value of initial value of A. So the read A, then the value of A, we will subtract rupees 50 from the initial value of A, that is A minus 50, then the write A. What will be the value of A? Let's say initial value is 100. So if we subtract rupees 50 from the A, then its final value is 50. So write transaction. These are the two transactions, and we are saying that the from A we have to take rupees 50 and to deposit to B. So there are two main issues to deal with. What are the issues? Various types of failures. Like for example, if the transaction fails after the updation of writing A, then what will happen? The amount will be deducted from the A but will not be added to B. So the transaction fails in between. Or what will happen? If another person read the value of B before writing this value. So what will he read? The read B contains the previous value of B, not after the value of writing B. So these are some transaction failures. Like for example, the failure of various kinds such as hardware failure, system crashes, concurrent execution of multiple transactions. Like for example, this is the transaction T1, another is transaction T2. T1 is want to withdraw the amount from A and deposit the amount to B, and T2 transaction, in T2 transaction, some person read the value of B. So it will give the initial value of B. So this is the incorrect value of V. So these are the transaction properties, asset properties. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So basically, these are the property by which we can ensure that the transaction is fully committed, the transaction is fully done or not. If a transaction is completed and its write will be done or is done into the memory device, then the transaction is said to be complete transaction. So the first property is atomicity. What does it mean? It means that either the transaction is properly completed or not. It doesn't mean that the transaction is left in between some transaction. Transaction should be completed. If the transaction is not completed, then it should be rolled back to its previous value. So the second, consistency. The execution of a transaction isolation preserve the consistency of database. It means for what? If we want to execute a transaction, it should reflect the final value of change in A or B. It should reflect to all the databases. Isolation. Isolation, it means if there are multiple transactions are there, each and every transaction is independently or do not interfere to another transaction. Each and every transaction is independent transaction. The transaction is not much aware about the other transactions. So the transaction is obsolete, the transaction is independent. This is isolation. Durability. If a transaction completes, let's say we are saying that atomicity, a transaction is completed or not. If a transaction is completed, then what will happen? the reflection or the changes should reflect everywhere. Even if system crashes, then also the changes will reflect to all the databases. So this is the durability. If we follow these 4 rules, then we can say that we are doing a transaction that is complete, that is atomicity, the transaction is completed, consistency, that record should maintain its values, isolation, each and every transaction is isolated from other transactions, durability, the changes should reflect everywhere. Okay. These are the transaction states. When we start a transaction, so what are the different stages or states till the completion of transaction or till the abort or failure of a transaction? Let's say, for example, if a transaction starts, then active state, the first is active state. Active state is the initial state, the transaction stay this state while it is executing, it's starting. Okay. The next stage is either partially committed or failed. If the transaction is partially committed, or we can say that in the previous example, we are deducting the amount ₹50 from A and adding the amount to B. If the transaction fails, suppose A, the ₹50 has been deducted from the A, then it is partially committed. If failed, it means it is not completed. So the transaction will no longer proceed. So either the transaction is partially committed or the transaction is failed. If the transaction is partially committed, then it can be committed, it can be complete transaction, or it can be failed. Suppose a transaction is not completed due to some error, due to some failure, then it has to fail. If the transaction failed, then it is aborted and it is rollback. Rollback, it means the previous value of all the variable should retain. And if the transaction partially committed, then committed, it means the transaction, the final value, the changed value should reflect everywhere. So these are the 5 states are there: active, partially committed, failed, aborted and committed. Okay. Concurrent execution. Let's say, for example, if we are talking about the transactions, there are many operations are there. If these operations are done serially, then it is called a serial transaction. Okay. So, but we are using a good computer configuration. So if we are doing the transaction serially, so it is time killing, or if we can execute multiple transactions at a time, so we can do to save our time, to reduce the average response time, to basically to utilize the processor power. So we have to do multiple transactions at a time, or we can say multiple transactions are allowed to run concurrently in the system. This is called concurrent execution. Just to have the following advantages, like the first one is increased processor and disk utilization, and second is reduce average response time. Okay. But there are many disadvantages using concurrent executions. For example, if transaction T1 is there in a schedule, there is a T1 transaction and there is a T2 transaction. T1 wants to change the value of B and T1 wants to read the value of B. So there is a conflict. If T2 transaction read the value of B before it's write by T1, then this is a dirty read. It gives the initial value of B, not the after write into the B. So these are the various problems. So we have to manage it by various concurrency control schemes. Okay. So we will discuss about it later. First, we will discuss about the transaction processing concepts. So schedules. A schedule. What is a schedule and what is a transaction? Transaction has many operations and a schedule has more than one or more than one transaction. A schedule can have more than one or more than one transaction, and a transaction can have more than one or more than one operations. Okay. The schedule is a sequence of instructions that specify the chronological order in which instruction of concurrent transaction are executed. Schedule, it is a set of transactions also, T1, T2, T3, these are the transactions, and T1 contain the operations on A or B, like that. Okay. So this is the example of schedule. Let's say we can consider the previous example, like for example, this is a schedule. In this schedule, T1 is a transaction and T2 is a transaction. So we can say this schedule can have, this schedule has two transactions, T1 and T2. In T1, read A and deduction of 50 from the initial value of A, then write A. Read B, addition of 50 into B and write B and then commit. The transaction is completed. In T2, it read the initial value of A, not the initial value. After this write A, after this write A, it will read the value of read A. Okay. Temp A is equals to A into 0.1. It means its percentage 10% of A. A is equals to A minus temp and write A, its final write, and read B, B is equals to B plus temp and write B commit. So these are the two transactions in a schedule. In a schedule, these are two transactions, and these two transactions are concurrent transaction. We can say concurrent transaction. But after T1 executes completely, then only T2 start. After the completion of T1, T2 start. So the schedule is first is T1 and then T2. First T1 execute, T1 completes, then T2 start and T2 completes. Now let's take another example. This is a serial schedule 2. In the previous schedule, we have seen that T1 transaction execute first and then T2 transaction execute and finish. So the order is T1 and then T2, and in this transaction T2 start first, finish it first, and then the value of T1 transaction begin and finish. So in this schedule we can say that T2 start first and then T1. So these two are the serial schedule, one by one. In this schedule, T1 or T2, whatever it execute, so T1 or T2. In this case, what has happened? In this case, okay. In this case, T1 and T2, these are the concurrent transaction, and the schedule is treated as T1, then T2, and then again T1, and then again T2. So it will read the value of A, and then in T2 it read the value of A, and in T1 it read the value of B, and in T2 it read the value of B, and then do some operation, do some changes in T1 and in T2. So this is not the serial transaction, just because of T1 and T2 parallelly are executing. This is called, we can say that this is a concurrent transaction. So this is not the parallel transaction, but the following schedule is not the serial, but it is equivalent to schedule 1. And what is schedule? This is schedule 1. In schedule 1, it read the value of A, do some changes, read the value of B, do some changes, and then start the transaction T2. And in this scenario, it read the value of A, read the value of A by T2, read the value of B in T1, and read the value of B in T2, and then do some changes also. So these three schedules, schedule 1, schedule 2, schedule 3. Schedule 1 is T1 to T2, schedule 2 is T2 to T1, and schedule 3 is this one, T1 then T2 then T1 T2. So can we say that the final value A or B is the same in these three schedules? Let's check. In this scenario, whether we are able to find this type of thing, in concurrent transaction, we can say that the final value of A and B is same or not. Let's say the following concurrent schedule does not preserve the value of A plus B. Does not preserve. Check. Read A. The starting point is A is 1000. We do subtract 50 from A, then it is 950. Read A. It is not right A. There is not a right A. So what will it read? It read the initial value of A, that is 1000. It will not read the 950 just because of transaction T1 didn't write A. Okay. So it read the initial value of 1000 and then temp do some changes and the write A. It write the A 900. Read B. Initial value of B is 1000 and then write A. Write A in T1. So T1 continue from this to this. So here the final value of T1 is 950. So it write the value of A as 950 while the value of A has been changed to 900. This is the problem. Read B. 1000, 1000, B plus 50, 1050, write B 1050. And in this case, B is equals to B plus temp. And what is the value of temp? Temp is 100. So it read B 1000, but it write B. So 1050 plus 100 because it's already write B. It has changed the value of B. So what will it consider? It consider this changed value of B plus the value of temp. It means 1050 plus 100, that is 1150. So what we can say that this is not the serial schedule. This concurrent schedule is, yes, obviously this is concurrent schedule, but this is not the correct schedule. We have to do write operation immediate after some changes, and then only the read operation will execute. So these type of small things we should consider, that every read should be only after the write operation. Okay, seriesability. So these are the cases where we have to study seriesability cases. What is seriesability? In a simple language, a schedule which is not serial but can be converted into a serial schedule. In a very simple language, a seriesability is a schedule which is a non-serial schedule, but it can be converted into a serial schedule. For example, if it is not a serial schedule, it means it is a concurrent schedule. Okay. If it is a concurrent schedule, then it should never happen that the final value of A or B has been changed as per the serial schedule. The final value of A and B should remain same in serial schedule or in seriesable schedule or concurrent schedules. Then only the particular case is treated as the seriesability. Okay. So seriesability, what is seriesability? Each transaction preserve database consistency. It means if a serial schedule gives the final value of A and B, whatever the value is, the same value, final value of A and B gives by the seriesable schedule, then only we can say this is the consistency. Okay. So there are two types of seriesability: conflict seriesability and view seriesability. Okay. So we will discuss about one by one. But before discussing this particular seriesability schedule or view seriesability or conflict seriesability, we should consider different types of anomaly due to this interleaved execution. Basically, if two operations on the same data conflicts, if at least one of the item is written by the T1 or T2. Okay. So anomaly can arise. There are different types of anomalies. The one is lost update problem, that is called a write-write conflict. If T1 write and T2 also write, then there is a write-write conflict. Another is a dirty read. If T1 write and T2 read before that particular write, then it read the initial value of that particular variable. So dirty read. An unrepeatable problem, that is read, different types of read in different transactions. Let's discuss one by one. So this is the example of lost update problem. Okay, see this. A transaction override the value of data item, say A, which has already been modified by another transaction. Let's say example, the initial value of A is 1000. So read A, it gives 1000. Okay, 1000. A is equals to A minus 100, it means 900. Okay, in T2, it's read the initial value of A. Just because of this T1, do not write the final value of A here before this read transaction. So this read will give the initial value of A, that is 1000. Okay, A is equals to A minus 200, it means 800, and write A. It write the final value 800. So in this scenario, A is 100, but this T1 transaction write the value of A after deducting 100 from its initial value. So this A gives 900 and this A gives 100. So this T1 and T2 produce different results, and this is not good. This is the useless transaction. So the transaction is T1 overrides the on transaction T2. The transaction T2, the value of written by the T2 has been overwritten by the transaction T1. So this is called lost update. We have updated the value in T2, but it is lost just because of its write operation overwrite this. So this is called overwrite. It means we can say the write. This is right, this is right. Write one after one. Okay. This is the case of lost update. It means any change in any variable has been updated by another transaction. It will not read by the different transaction. Okay. Next issue. So this is the case of dirty read problem. Dirty read problem is what? If one transaction has write the value of A and another transaction has read the previous value of A, just because of if any transaction write the value, change the value, and it's rollback. So what is here? Dirty read. Another transaction read the final values, but this is not this should not be done. So this is the case where we can say that this is a dirty read. It's read the false value. It's read the false value just because of another transaction has changed and rollback. Changed but rollback. Okay. So this is a dirty read problem. The third is unrepeatable read problem. Unrepeatable read problem. So what is this case? This is the case when a transaction tries to read the value for a data item 2 times and another transaction update the data item in between that particular 2 read. Like for example, this is read A and this is read A. Okay. Listen carefully. Read A, and what T2 does? T2 has changed the value of A. T2 has changed the value of A. So it read the initial value of A, but it read the final changed value of A. This is called unrepeatable read problem. So we can overcome by do not either this read should not be done or this read should not be done. But if this read is not done, then it's read the initial value. So this read should be obsolete. So read only write is allowed. So this is unrepeatable read problem just because of read and write. Okay. Conflicts instructions. Like for example, if an instruction II and ij of transaction Ti and Tj, this is I1 and I2, T1 and T2, we can say that are conflicts. If and only if there exists some data item or variable accessed by the both of the transactions I1 and I2. Like for example, if I read the particular value and ij read the same value, then ii and ij do not conflict. Read. Just because of two different transactions read the same data. Like for example, this is a T1 schedule and this is a T2 schedule. Whatever the value of A, it read the A variable, it's read A. So it gives the same result now. If it gives same result, then there is no problem. But if one is read operation, another is write operation, then it is a conflict. If there is a read operation, another is write operation, so there is a conflict. In the conflict case, we should follow the write before the read operation. These two transactions cannot be done parallelly. In the same case, write read, this also, write write, this also, just because of it overwrites. It's overwrite, basically the previous problem, read update, or these are the problem, anomaly, dirty read, or the lost update problem. Just to see, these are the cases. So we should follow only this case, that if there are two read operation, then this is a not conflict, otherwise it conflicts. Okay. So intuitively, our conflicts between ii and ij force a logical temporal order between them. Okay. So conflict seriesability, this is the main important topic, just because of there are some numerical questions. You have to check whether this particular schedule is a conflict serializable schedule or not. So if a schedule S can be transformed into a serial S dash by a series of swaps, it means for what? If a schedule, we are swapping the transaction, listen carefully, we are swapping the transaction, but the final value of the variable should not changed, and it converted into a serial schedule. It converted into a serial schedule, then it is called conflict serializability. So what is written? If a schedule S can be transformed into a schedule S by a series of swaps of non-conflicting instruction, we say that S and S dash are conflict equivalent. These two transactions, S1, S and S dash, both are conflict equivalent, just because of S is a serializable schedule and S dash is serial schedule after swapping some variable. Okay. Let's take an example. This is a case where T1 and T2 are concurrent. This is a serializable schedule, and this schedule is a serial schedule. We have swapped some variable. What? This read variable, read B, this side, and this side. Just do this one and make it this. The final answer of T1 and T2 remain same, but the schedule has been changed. This is a serializable and this is a serial schedule. So these are conflict equivalent schedules. S and S dash schedule 3 and schedule 6 are conflict equivalent schedules. Okay. This is the example that is not conflict serializable, just because of read, write and write. We are unable to swap the instruction. We cannot do this. So this we cannot do this. Okay. So this is not the conflict serializable. View serializability. This is another type of serializability. One is conflict serializability, another is view serializability. In view serializability, we can say that there are two schedules, S and S dash. These are the view equivalent if and only if these three points followed. If a schedule S, transaction Ti read the initial value of Q, then in schedule S dash also must read the initial value of key. It means T1 and T2, both read operation are allowed in both the transaction on the same variable, like read A and read A. In both of the transaction, read operation on a same variable is allowed. The second is, if a schedule S transaction Ti execute a read operation and that value was produced by the transaction Tj, if any, then the schedule S dash also must read the value of Q that was produced by the same write operation of the transaction Tj. It means for what? If one schedule has changed the variable, changed the value of variable, another transaction read the changed value of that particular variable. So this should be done. The transaction, if any, that perform the final write operation in the schedule S must also perform the final write in schedule S dash. Means if there is a final write in T, then a final write in S, then final write in S dash also. So V equivalence is also based on purely on read and write alone. Like for example, this is the case. Let's take one by one. A schedule S is view serializable. This is the view serializable. If it's a view equivalent to a serial schedule. Number one. Number two, every conflict serializable schedule is also a view serializable. Every conflict serializable. Okay. This schedule is a view serializable, but it is not the conflict serializable. It is a view serializable just because of final write. It is a view serializable, just we can say that we have followed the different types of a view serializable condition. So this is a view serializable, but it is not the conflict serializable schedule. Testing of seriesability. Now we have to test whether the particular schedule is a serializable schedule or not. So we have to test it by making a precedence graph. Okay. So precedence graph should be acyclic. If the graph is acyclic, then we can say that this schedule is a serializable schedule. If it is a cyclic graph, then the schedule is not considered. And so let's say, for example, if there is a schedule T1, T2, and this is a cyclic graph, so this should not be done. The precedence graph should be acyclic. Testing for conflict serializability. Let's take an example. A schedule is conflict serializable and only if precedence graph is acyclic. The precedence graph should be acyclic. Okay. And if precedence graph is acyclic, the serializability order can be obtained by a topological sorting of the graph. Topological sorting. Like for example, this is a schedule A, T1, Ti, Tk, Ti, Tj, and from Tj, Tm, from Tk, Tm. Okay. So the first transaction is Ti, then we can say that Tj, Tj, then Tk, and then Tm. In the similar fashion, Ti, rather than initiating Tj, we can initiate Tk first, Tk, and then Tj, and then Tm. Okay. So this we can say topological sorting. So there is another example, right? There is a schedule. This is a schedule T1, T2, T3, and T4. This is a schedule. The T2 transaction read the value of X, T3 write the value of X, T1 write the value of X, T2 write the value of Y, T4 read the value of X, and T2 read the value of Z, and T4 read the value of Y. This is the transaction. So we can say that first T2 transaction begins. So R2 X, this is an T2, and then W3X, this is an T3. Then another is R2X to T1, W1X, T2 to T1. Another is W3X from this to this one, W1X, T3 to T1, and W3X this to R4X, this one. So T1, T3 to T4, and this Y to Y, it means T2, T2 to T4, T2 to T4. Another is T1 to T4, WX to RY. So these are the different transactions. We have marked each and every transaction. Now we make a precedence graph. Like for example, T2 is here, T2 to T3, T2 to T3, we have drawn it. T2 to T1, T2 to T1, we have drawn it. T3 and T1, T3 to T1, this is T3 to T4, this is T1 to T4, T1 to T4, this is, and T2 to T4, T2 to T4. So now check whether there is a cyclic graph or a cyclic graph. If we start from T1 to this, no, stop here. If we start from T2, from this to this to this, stop, this to this to this, stop. So this is not the cyclic graph. So we can say this is a serial schedule, and this schedule can be written as T2, T3, T4, T1 and T4. This is a possible serial schedule. So this is how we can check the seriesability of any schedule. A transaction should be seriesable if it can be converted into a serial schedule, then only it is a seriesable schedule. Okay. So this is another example, and we can say that there is no cyclic, so this is a acyclic graph. So this schedule is also the conflict seriesable schedule. Okay. So thanks for this. So in the next session we will continue next topic. Thank you.